How do you order rational numbers? How do you put them in order from small to large or large to small, whichever way the problem asks? Well, one really easy way to do it is to use this theorem. So the theorem says if a, b, and c are integers and b is greater than 0, then a over b is greater than c over b if and only if a is greater than c. What they're trying to tell you is if you could make the two fractions have the same denominator, all you have to do is compare the numerators. See the a and the c? And if a is bigger than c, then a over b, that fraction is bigger than c over b. So the trick is make everybody have the same denominator, and then you can just compare the numerators as long as you've got the same denominator. So that's what we're going to do to order these fractions. So it says put in order from smallest to largest. So the smallest one's going to go in the first blank. So like small, medium, large is what we're looking at. And these are the fractions. Notice none of them have the same denominator. So let's work on trying to get them to have the same denominator. We're going to create equivalent fractions, and then we can just compare the numerators. So the easiest way to come up with the common denominator is just to multiply the three denominators together. When you are like unreducing or unsimplifying or blowing up the fraction, as I call it, go big or go home. It's easier when you have a bigger denominator. So if I do 8 times 5 times 6, you can just use a little calculator for this, you're going to get 240. We're going to use that as our common denominator. Common denominator. 240. All right, so I'm going to take 7/8 and I'm going to change it into a fraction that has 240 in the denominator, and I left some space there on purpose. So let's think about what could we multiply 8 by to get 240. And if you don't know, you can just divide it on a calculator, but you could multiply by 30. Basically, what would you multiply 8 by? The other two guys, which is 30. So I'm going to multiply by 30 and multiply by 30, and that's going to give me 210 on the top. So 210 over 240, that's what 7/8 is. Now we're going to play the same game with 2/5. Try to turn it into a fraction with 240 as the denominator. So what would you multiply 5 by? Well, I'm going to cover up the 5 here. Multiply by 8 times 6. You'd multiply by 48. So multiply the top by 48, multiply the bottom by 48. If you multiply those by 48, you're going to get 96 on the top. So I already know 96 over 240 is smaller than 210. I've already, I can order those two. Now I just have to do the last one. The last one is 5/6. Again, I want it to have 240 as my denominator. So if I don't use the 6, I'd multiply by 40. 6 times 40 is 240, 5 times 40 is 200. So now you can just compare the numerators, and I've got them here in red. So 210, 96, and 200. Which one is the smallest? It would be this guy. So my smallest one is 2/5. So I'm going to go ahead and put 2/5 right there because that's my small one. And then between 200 and 210, the biggest one is the 210. And that came from 7/8, so that's my largest. So then my middle one is the 5/6. So that's how you can order them. Just create a large denominator, and then you can just compare the numerators. Another thing that's really important to do is to be able to compare fractions to a half. That's a pretty common comparison. So this says decide if each fraction is less than a half, equal to a half, or greater than a half. Sorry, let me cover all this up. So I think we need to talk about what would a half look like in these different languages, right? If we're going to try to figure out less than a half, equal to a half, or greater than a half. So what do I mean in the languages? Like, do you see how some of our options here are thirds, then we have some sixths, and then we have some eighths. So these numbers, we want to pick them up and drop them into the correct grouping. So let's talk about what a half would look like in thirds language. So if we're dealing with thirds, what is half of 3? Well, it would be 1.5. So 1.5 out of 3 would be how you say a half in thirds language. 1.5 out of 3. So if 1.5 out of 3 is equal to a half, then how would 1/3 and 2/3 compare? Well, 1/3, 1 is smaller than 1.5. So 1/3 is smaller than a half, or less than a half. So I'll put 1/3 here. 2/3, 2 is bigger than 1.5, so 2/3 is bigger than 1/2. So I'll put 2/3 over here. I don't have one that was equal to a half that's in thirds language. Now let's look at these sixths. In sixths, that's so hard to say for me. Half of 6 is 3. So 3/6, that's how you would say 1/2 in sixth language. So 3/6 is equal to a half. So 2/6, you see that's smaller than 3/6. So 2/6 is less than a half. Whereas 4/6, see that's greater than what we call a half in sixth language. So 4/6 would be greater. So that guy would go there. And now let's talk about how would we talk about halves in eighths language. Eighths. That's hard to spell also. So half of 8 is 4. So 4/8, that's how you say 1/2. Oh, well, 4/8 is one of the numbers that we have to stick into one of these groups. So 4/8 is actually equal to a half. So that one's going to go right there. There's my 4/8. And 2/8, see 2 is smaller than 4. So 2/8 is smaller than a half, less than a half. So it would go there. So now we've got all 6 of the numbers arranged. So you need to think about what a half looks like depending on what your denominator is, the language, like the fraction language that you're speaking. And then you can compare to 1/2 a lot easier.